Hey everybody, so in this video we're just going to look at how we calculate the area and perimeter of a rectangle. So let's first of all just talk about what the two terms mean. Area is the amount of space that a shape takes up. So if we look at these two rectangles here, for example, we can tell straight away that one of them takes up more space. So that's what area is. It's just a measure of how much space a rectangle takes. So calculating area is actually handy enough. All that we have to do is multiply the length of the rectangle here by its width here. So simple formula, area is equal to length times by width. And we can find that formula in our log tables, so we don't need to know it off by heart or anything. Let's say for this rectangle, the length is 8 meters and the width is 2 meters. To find the area, we're going to write out our formula. Area is equal to length times by width. Then we sub in the length, which is 8, by the width, which is 2. So our area is going to be equal to 8 by 2. Keep writing our next lines underneath, not to the side, so it keeps track of where everything is for us. Then 8 by 2 is 16. Whatever units we put in when we're calculating area is just measured in squares, right? So we have meters that we put in, so our area is going to be measured in meters squared. Let's say the smaller rectangle here, if you want to do that one, if that one was measured in centimeters, so this might be 50 centimeters by 20 centimeters. To do our calculation, we just say area is equal to length by width. If we wanted to find the area here, our length is 50 centimeters, our width is 20 centimeters. If we multiply them out, 50 times 20 gives us 1000. And because we put in centimeters this time, we're going to get out centimeters squared. So just remember that with your units. Centimeters have to be squared, and we're always trying to remember our units when we're dealing with area and perimeter. Now we can look at perimeter. So the perimeter of a rectangle is just the sum of all the sides. That's what we get if we add up all the sides of the rectangle. So if we go back to a rectangle that was 8 meters across and 2 meters high, to get the perimeter, we're just going to add up all the 4 different sides. Now, some people, to think of perimeter, they like to imagine if you start off at one corner, say here for example, and walk the whole length of the rectangle. So you'd walk 8 meters this way. So we're going to go 8 meters, then 2 meters down here. So 2 meters down this way, then 8 meters back here. We know that this side length is the same as the opposite side. So you can say that this is 8. And for the same reason, we can say that this is 2. So we're going to walk 8 meters back along the bottom. So we've gone 8, 2, and 8, and then another 2 meters to finish our journey. So another 2 here. So again, that's 8 plus 2 plus 8 plus 2. This will give us overall 20 meters. Now, perimeter is still just a measure of distance. So it's not meters squared or anything fancy. It's 8 meters plus 2 meters is going to be 10 meters. Plus 8 meters is 18 meters, plus 2 meters is 20 meters, right? It's just a distance, it's not area, so we still measure it in meters. Now we're going to look at calculating the area and perimeter of a shape that looks like this. So it's a little bit more complicated, but the thing that we can remember is that this shape here, hopefully you can see it's like a big rectangle that has a little smaller rectangle cut out of it. So it might be easiest to start with the perimeter in this case. What we're going to do is try and figure out all the side lengths. We know 6 here, we know 10 across here, but then we just need to figure out some of the other unknown ones. So let's look at this bottom one along here. This is 10 meters to go from here to here. So it's similarly going to be 10 meters if we go from here all the way over to here. Now if this part here is 1 meter and the total thing is 10 meters, Then 10 take away 1 is going to leave us with 9 meters here. I know it doesn't look like 9 on one of my diagrams, but I'm doing my best. Alright, so this distance will be 9 meters here then. All that we did was got 10, the total length, and took away 1 to find the remaining part of that length here. For our other distances, we have 6 meters of a height here. So if we want to find the opposite, right, what we do is we start off at 6. We know that it's 3 up to here, so to go the rest of that way, must be another 3 to make up the rest of the 6. So this here is 3 meters, so the end of this thing here is 3 meters as well. Now you can do that out in rough work. It's probably the easiest way to avoid overly cluttering your diagram. But if we wanted to find the perimeter, then what we do is just add all those side lengths now. So again, you can imagine starting off here, you're going to walk the entire outside of the shape. So first of all, you're going to walk 10 meters. You're going to walk 3 meters down here. So we'll add 3 on. Then you're walking 1 meter in towards here. So we can add 1 on. Then you're walking 3 meters down here. So we can add 3 on. Then you're walking 9 meters back to this corner. And then 6 meters back to where you started from. So our total perimeter here, when we add it all up, is 32. Now we have to be really careful when we're dealing with area and volume, not to forget our units. So because they gave us units in the question, everything was measured in meters, we're going to stick units in our answer. So the perimeter is 32 meters. Now I'm just going to remove some of the rough work we have drawn around this diagram, and we're going to find the area. So this is why I recommend drawing it out as rough work on a sheet of paper somewhere, just so if you were given an original diagram in an exam question, you don't ruin it by doing scribbles all over it. Better to just do it into a rough work sheet. Okay, so if we want to find the area of this shape now, the amount of space that it takes up, what we can do is kind of interesting. We're going to get the area of the big rectangle, and we're going to take away the area of the smaller rectangle. So the big rectangle, you can see it in here in green. I'm going to highlight it. Not doing a great job, mind you. There's our green rectangle. We're going to take away the area of the smaller rectangle, which we can put in here in red. All right, so the area of the green one, I might write it in green just so we can keep track of how we're getting on. So area is going to be length times by width. So for the green one, that's going to be 10 times by 6. So 60 meters squared. For a red little shape that we're taking away, it's going to be length by width again. So area is equal to length by width. Our length is 1 meter, and our width is 3 meters. So 1 times 3 gives us 3 meters. And of course, because it's area, that has to be squared. And then what we're going to do is take the small area away from the big area, right? So you can imagine we have a big green rectangle, find its area, find the total space it takes up, then take away the space of the red bit that's missing. So our total area, or our final area, if you want to think of it that way, is going to be 60, take away 3. So 57 meters squared.